I like this one. Okay. So a set of 10 teams held a round robin tournament in which every team played every other team exactly once. Each team won 10 games and lost 10 games, but there were no ties. How many sets of teams A, B, C were there in which A beat B, B beat C, and C beat A? So firstly, we know that the number of teams is equal to 20 because each team played 20 games. Each team played 21 games, so there's 21 teams. And so the next observation is that each triangle it only has two possible forms. It can either be there's two types. There's type 1 and type 2. Any triangle with like directed edges, where like A to B means that A beat B. So we like use arrows to signify win. So each triangle like this has two forms. Type 1, where there's a cycle like A B B, B B C, C B A, or it has to be of this form, in which, importantly, for in our case, there's one team which beats the other two teams. And there's also one team which loses to both teams, to both of the other teams. But yeah, these are the only two types. And so the question is actually asking for the number of type A's, so type 1s. So yeah, the problem is asking for the number of type 1s because each of these type 1s, there is like exactly one way. Yeah, for each of the type 1s, there's a way to write them as like write them as like A beat B, who beat C, who beat A. And so yeah, we have the number of type 1s equal the total number of triples minus the number of type 2s. And this is because there's only type 1s and type 2s. So if like this is just rearranging of number of type 1s plus number of type 2s equals the total number of triples. And the total number of triples is 21 choose 3. Because 21 choose 3 is just the number of ways to choose 3 teams from the total number of 21. And the number of type 2s, importantly, we select for the number of ways, we count the number of type 2s based on the number based on like this guy. So like each type 2 corresponds to one player X who and then a pair. So like each type 2 triangle corresponds to one team X and then a pair of teams that X beat. So the number of such triplets is 21 times 10 choose 2. Because there's 21 teams and each team has 10 choose 2 pairs of teams which they beat, which equals, I don't remember the exact numbers. Oops. Let me check. Yeah, so it's 21 choose 3 minus, so it's 1330, whatever, I'll just recalculate. Okay. 45. So yeah, it's 1330 minus 945, which equals 385. And that's your answer. I think personally that this problem is slightly unclear because sets is weird. This is Actually, wait, that's fine. Okay. So the main idea here was that there's exactly two ways to set up a set for any set of three teams. Yeah, for any set of three teams, either if you can't find like some ordering in which A, B, 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 C, and C, B, A, then like you can find there's exactly one team which beat the other two teams, and based on that we can count the number of ways, the number of like we can count the number of triplets which have one team beating two other teams through something called double counting. That's what we did double counting here to get these things were equal. All right.